we treat from 3 cities, Tri-City plant, Oregon City, Westland, and Gladstone. We have 5 influent pumps. The 3 big ones do 12,500 gallons a minute, and 2 smaller ones do 5,000. And basically, they're running on VFDs, but we tell them to maintain a 6-foot level in the wet well, so they ramp up or down when the level goes up or down. So I can open it up. You guys can take a look if you want. Like, what was the definition without VFD yet? Variable frequency jets.
What's the reason that you pumped it down to 6 feet?
We just try to maintain 6 feet. High level's 12. So
You think they can get any deeper?
on up to the bar screens.
I was controlling all myself.
MBR screens. We have 2 grit chambers here, and three grit pumps per chamber. And they pump it up to this building here too. Goes through the cyclone degritters, and that's all to landfill also. One load a week. Yeah.
You know where it's going?
Grit and rags.
You know what landfill we're taking to?
What landfill? Coffee. Back here you see the sample hut. We have them all through the plant. We have a tick sump plug for the Kellogg plant, about 1 or 2 MTB. And so we have an immersion sampler, influent, primary effluent, secondary effluent, final effluent, and MBR. So we can track how we're doing, how each process is doing, the BOD and PSS, whatever we want. The lab does most of our testing for us. So. MBR plant, the one that just came up on a few weeks ago. Membrane bioreactor. Yeah, we'll look. That's how they work. Yeah. That's right, kind of alternate. There's sometimes where, right now they're replacing some sprockets and putting all new chains on them. Just making sure, basic, just inspect, making sure it's not immediate to go off the sprocket. So just making sure it's as far as time on maintenance, replacing the chain, that's what they're doing now. They're getting new sprockets. Oh, this is our weather station right here. So it tracks wind speed, rainfall, all of that, because we have to put it on our discharge monitoring board. I got a 67. Yeah. On the van, it has like wind speed. Yeah. Remember what I did? No, it's just for like all we put on there is on our discharge. Well, you know, if we have a violation, they can look back and say, okay, yeah, we got 2 inches of rain that day. So, yeah, we have really bad I-9. So, we have like an inch of rain in one day while high flows for a week. Pipes, yeah.
You guys planning on like replacing pipes?
process of that right now. Obviously, we've already expanded.
Yeah.
But
You're talking about
Yeah.
we're talking about the whole, yeah, Oregon City, all the collections. Yeah. Diversion, primary, secondary, final, all right, let's go.
Yeah, looks like a miniature version of your
two books. Basically, like 250 questions on
It's really cool because most MBR plants are using raw insulin, but ours has already had treatment, so it helps align with the membrane. And the front half of the plant will handle like 50 to 60 mgd, but the back half aeration basins only do 25. So at that end, you see that other gate, that's the primary blending gate, and once we get up too high, that gate opens and it goes straight to the contact basin. So it just gets primary treatment, gets hit with chlorine, and then off to the river.
Primary and chlorine?
Yeah. So the aeration basins are set up pretty cool because right now we're on plug flow, but if we get high flows, there's gates all along the sides of these, and that's where the primary effluent is entering. So we can go to the contact stabilization, hold back our solids, that way we're not washing out the aeration basins and violating on TSS or BOD. And so it's kind of like a step feed, but we call it contact stabilization. anoxic zones and then four zones of aerated. Month 12 means plenty of effluent comes in. Each zone there. So contact stabilization is when we actually will put the primary effluent down further, holding back solids in these zones. Right now we're close. So our blowers, we just that we've seen, they run at 26,000 RPM, and it only takes one of them for the air that we need. Our mixed liquor return pumps and the aeration basins are pretty cool. They were designed for fish hatcheries, fish without closing. So they're downstairs, but they're mixed liquors coming into this first zone also, as well as rats. You guys have any questions?
Where's the zone end for this?
There's concrete. There's concrete walls. So yeah, so this is one zone, that's one zone. Those two are anoxic, obviously. So over there. Yeah, this is the wall. There's a wall there and the wall here. Yeah, these are 20 feet deep. So no, it's just because we're returning. Our mixed liquor return pumps are doing like 2.5 times, 3.5 times the flow. So whatever flow's coming in, we're doing 3 or 3.5 times that. That's why it's just coming up over that wall. Plus RAS, plus primary effluent.
And the res is coming where about?
Over there.
In that corner over there?
It is over the surface of the wall, the only transition, or is the wall?
There's gates, we keep them closed, but we can't open the gates.
So the water goes over the top.
Over the top, yeah.
What's the from the wall itself, so not covered?
No, besides the gates. There is a small baffle at the, but it doesn't do much. So yeah, these all have fine bubble diffusers in them, just like we saw at Veolia.
So it's just coming out the side of the
These are for our step feed that we don't use because it was designed poorly when they built it.
What did it do?
You guys have a set goal for your RAS, like 20%? Or?
Yeah, so our RAS is running at 40% right now just because we're pulling some effluent off to run the MBR plant. So our RAS is based on secondary effluent flow. So it's looking at that and then timesing it by whatever we want. We right now 40%. Winter time 15%, 20%. Yeah, we used to have the old style sock diffusers like you guys saw at Kellogg, but when we built this plant, we upgraded to the fine bubble. A lot better surface area, saves on energy.
Cool. What's the design flaw of these guys, you think?
There's something with the walls, concrete walls. They've never used them, but this was for step feed, so we can have primary effluent come in here and feed different zones of the aeration basin, but we don't do that. So yeah, all the aeration makes an excellent flow, comes up into the center stilling wheel. No, we just stand right here.
Yeah.
You want them ducked like that. You don't want them clear.
Are those all duck feathers in there?
That means it's all
Those are all duck feathers. No, it's cottonwood. Never mind.
Thursday was okay. Yeah, yesterday was the day that we
So these are 18 feet deep. And this scum collector arm you see there, there's a device connected to it called a towbro, and it's just a tube with small like holes on it, sucking the solids off the bottom. And that's what we're either returning or wasting to the digester. You guys use the sponge down there?
That's called a stilling well.
But I think it's something else. Did you like it? Was it good? What do we got here? He's still doing his shit of eating stuff, right?
That's different.
Scrubber turns on automatically.
Mike, I got a question for you.
So, was there a penalty?
Go ahead.
It's usually minor when we're putting chlorine cylinders online. Back to negative. And so a bad connection, a little pinhole in the hose, something like that. It's ammonia, permatex, so it goes super loud. I've had 2 leak on them. But
You have to wear a mask?
yeah, we have to wear a mask.
What?
So,
Why have you covered all your storm drains?
oh, because they're doing construction. They did that. The construction guys.
It's not putting sludge.
No. That brings up a good point. So when we expanded back here, we put in a bioswell back behind the fence. So all of our stormwater used to go to the Clackamas, but that'll hold a 100-year storm now, so we don't discharge any rainwater, any stormwater to the Clackamas. So it's pretty cool.
What do you guys call that?
Bioswell.
So they've got it on a separate system completely?
So all of our storm drains that used to go to the Clackamas now just divert right into there.
How much will that hold?
100-year storm. So it's quite a bit. Not much.
96.
Yeah. Alright, so we got 2 digesters, about 1 million gallons apiece. All the primary sludge, the walls from the secondaries, MBR walls, it's all getting pumped to the primary digester on the other side. Sits there 15 to 20 days, and then we transfer it to the secondary one here. Back there you guys can see the incinerator for when we're producing too much methane. We do use methane to run our engine generator, which we use to heat our #1 digester, our primary. We don't heat our secondary, but it still stays around 100 degrees just from the mixing. So after that, we pull out of the bottom of this one, hit it with some liquid polymer, and send it through a centrifuge, and comes up this conveyor, and we load it into trucks. That one's already done for the day. So we call it cake. Haul it over east and spread it on wheat fields. So I don't know, you guys want to see a GBT? I know you've seen them all, but
Sure.
all right.
Can you actually watch these movies when you get home?
No, I'm not sure if I have that much time to do all that. Brought my dog up there.
Once we get down to where we're
Swimming, running around here, across the streets,
depends on flow. Summertime, they'll last a long time. But wintertime, going through like straight, using 200-300 pounds a day. So secondary effluent flow comes through this partial plume. Chlorine is introduced right here. This is our flash mixer. And then we have 2 serpentine chambers for contact time. And obviously sodium bisulfite for dechlorination. We test, what's that? Depends on the flow, but probably 2-3 hours. Behind us are the odor control towers full of activating carbon. So all those buildings have odors there, vents, piping, pumping it to these towers. And then our effluent goes down and blends with MBR effluent. So cleans it up even more before it goes to the landfill. Temperature is not on our permit, but it'll probably be done. We had DEQ was gonna issue like a 15 milligram per liter ammonia limit, but we were able to put in a new diffuser on our effluent pipe, alcohol pipe. So they said if we did that, we won't get hit with that ammonia limit, which is good because yeah, so if we had a 15 milligram per liter limit, it'd be hard. It's hard to meet. We'd still try and keep it in single digits. But all right, should we go see the MBR plant?
Part 2.
Are you?
Should have went in there and smiled.
Nice. Photobomb. Hopefully you're not scrunched up there with your knees in your chest, but.
Sounds like it's supposed to say we saw it. Water. All right, listen up.
Remember the big filters they had?
Yeah. So, primary effluent flow. Remember we saw that box. We pull some of that primary effluent and it feeds the MBR plant.
So
And
it directly comes off, and so it's not hasn't been treated at all. Some of it that comes here, whatever comes here
well,
has
it's
been
been
treated.
through bar screen.
Well, other than that.
Primary treatment.
Oh yeah, I guess that.
Yeah. So. Yeah. So you know most of the solids, well not most, some of the primary solids.
It's a lot of lime.
Yeah, so we fully nitrify and denitrify on this plant, so it takes a lot, brings our pH down a lot. We go through 15 tons of lime usually every 2 weeks for pH adjustment.
This is fully
Yeah.
nitrify and denitrify?
Yeah. So, and this road we're standing on right here is pervious pavement. They kind of designed it to, so this all the rainwater just seeps underneath here and then goes to that bioswale too. Pretty cool. No, yeah.
This is asphalt with that stuff.
And the sulfur or the lime, that's in the liquid or?
It's a powder, but we make a slurry. It drops it into a slurry tank, and then the piping goes all the way down to that drop box. So we're dosing primary effluent with lime for pH and alkalinity. And we tell it, like, if we start getting high flows, we just type in how much we want to come to the MBR on the HMI. So on the SCADA, we just say, right now we're doing 2 MGD. That's usually where we keep it. But when we have high flows, we've peaked it at 10. I've seen it at 9 for a week. And 10 is peak hour flow, so we pushed them pretty hard. No, we have used sodium bicarb because we've had some upsets, but we haven't in the past year, probably.
So when you say the 15 tons of lime every 2 weeks, you said, is that based on the 2 million gallons?
Yeah. So all the centrate that comes off the centrifuge, all the liquid that comes out of the solids, we pump it over into these tanks over here. When they built it, there's four membrane trains with room for 4 more for expansion. We're using the other 4 for centrate basins because of that ammonia limit we had. So we kind of meter it in, and that also takes a lot, lowers your pH, takes a lot of alkalinity, so that's why we go through so much lime. He'll find a way.
Okay. Is there somebody here 24/7?
What's that?
You guys, is there staff together?
No, so there's 3 of us here Sunday through Thursday, 6 to 2:30, and then 3 others that are Tuesday through Saturday, 6 to 2:30. So there's someone here 7 days a week, but SCADA monitors when we're not here.
And then you guys do a call.
Yeah, there's a call out list.
And then so how often do you call out the ship? Once every 4 weeks?
No, it depends. The list rotates.
So then are you, if there's no incident, you get paid?
If you get called in. No,
Only
you
if you
don't.
get called in,
Yeah,
you get
only if
paid
you get
for a
called in.
couple hours.
You get 4 hours overnight, no matter what.
Hey, Blake, where are your green roofs at?
Green roofs are on every building.
Every building's got a green roof.
Yeah.
Wow.
So, OMSI kind of teamed up with us for all these signs. So when we go through here, you guys are going to see a bunch of OMSI signs, and I think they're going to be doing it to our other plant too. So it kind of explains the process. This plant was designed for tours. They have wheelchair ramps, all that. So it's pretty cool.
Does those roofs require any maintenance?
Yeah, the landscape people take care of them, so we don't even worry about them. They come in like a couple times a month, weed them all, and all we do is supply the water, which is W3.
That is
Are you shooting this as clips, Ken? Like as he goes to each station, are you shooting it as individual?
pretty nice. Try to.
Alright, perfect, thanks. I'm relying on you today.
Okay.
So these do a really good job of filtering out like hair. Hair is a big problem for membranes, so these will filter out stuff as small as hair. See some like corn, stuff like that. A lot of grease. Grease is bad. Beds like that look like a sponge, and we're pumping odorous air through the bottom, and then we're trickling water down from the top with nutrients in it. We see Miracle Grow, and the bugs are taking care of all the odorous air.
Looks like Miracle Grow.
For nutrients, yeah. Yeah, so we have a nutrient tank. We just add a little Miracle Grow, and it comes in at the top. This is W3 water.
That's what you're getting plant with.
W3? Yeah.
Do you have a reclamation area at all, or?
We used to water outside the fence, but DEQ put a lot of restrictions on it, so we said, all right, we won't do that anymore.
Do you know how many acres you have?
20, I'm not sure, yeah.
And this is the centric here? Or what is this?
This is odorous air tower.
So this is coming from the
from all these buildings over here.
You're my son.
So the other side uses activated carbon.
Gotcha.
This one, we just use this tower. What's that?
You want to get help from the government to do this class, or
We got,
grants from the city? A lot of cities don't even know to try
They
to
do
take
water
advantage of
inside, right?
yeah, exactly.
You guys do use your effluent to water inside, though, right?
Yeah, and actually now we water outside, but just
Outside what?
well, on like the not like no like just like around here, yeah.
So, if the pipe going straight from here, or you're saying that like other places, like I can call you up and say, I don't want to.
Oh no, we don't do that. No. It's just here, just here. When I say outside the fence, I mean like
literally as far as the sprinkler is right here.
NBR. Yeah. So all the flow after the fine screens comes up into what's called, it's like a chimney pipe. It comes up right here and goes through this aeration basin before the NBR. 2 anoxic zones, just like the other plant, with 4 aerated zones. Before we go into the NBR plant, I'll talk to you a little bit about how it works, because it's pretty loud in there. They're continuously air scoured, so to keep solids from building up. So the air is coming up from the bottom. Right now we're in 1030 aeration. When we're in low flows, we'll be in 1030. So air comes on for 10 seconds and then it's off for 30 seconds. When we get high flows, it goes into 1010. So basically the way it's set up is the straws or fibers, a bunch of fibers put together as a module, a bunch of modules is a cassette, and a bunch of cassettes is a train. So we have 4 trains, each one has 9 cassettes, 48 modules per cassette. And we have room to expand for 4 more trains. So they each go through a 10 to 12 minute production cycle where we're pulling water out from the inside of the straws, and then they'll go into either relax or back pulse mode. So relax, they'll just get nothing, just sit for 30 seconds, and back pulse is when we're pushing treated water back through them to knock off all the solids. And we're only doing that 1 day a week right now because there's really no need for it. Why treat more water that's already treated, you know? So we're putting out NTUs of less than 1. Wow. When they get to 0.1, we know it's time to clean our turbidity meters because we know the water's not that dirty. Usually they're around 0.05, 0.04. Yeah, so they do a tremendous job. Yeah. So each train goes through a maintenance clean once a week. We use liquid sodium hypochlorite, 12.5%. So we're just pulsing hypochlorite and back pulse water for like a 13-step process just to clean all the organics off. And then once or twice a year we'll do the inorganics, which we use citric acid. So we can go through here. There is a display module up so you guys can look and see. The membranes are underground, you're not going to be able to see them, and we can't really walk over the grating just because rocks, anything will damage them. So it's loud here, so I can't really talk much, but check it out. One other thing, the modules on each cassette are numbered, so you guys are going to hear some valving. Those are cyclic valves. So one valve will open, do the odd numbers, and then close. The other valve's open, and they do the even number modules.
Hey, when we went to the water treatment plant, they had a membrane filter process, and it was 0.02.
Yeah, these are 0.04 microns, so pretty small. Yeah. Yeah, they're a lot different. Yeah. So the water, we sit in the flow, we're pulling water from the inside of this tube on each one. So it's old. Yeah, so these are hollow, but they just have that coating around them with the small pores on them. So we're pulling water from the top and it's getting air from the bottom. And each strand, one of these strands can hold like a 12-pound bowling ball. So they're really strong, but if you scratch them like with your fingernail, they'll put a hole in them. What's that? Don't step on these, right? Yeah, try not to. So the aeration basin flow comes in over there and goes back around and then comes into each tray. And here's where we're pulling the permeate water out. And these are the areas. So on side, inside, and then permeate. Yeah, these are like 12 feet deep, so you can't even see the membrane.
John, we're not supposed to step on it.
And it'll run this whole MBR plant, and it'll run our influent pumps and a few other things on the other plant to get us by.
How long will it last?
It runs out of diesel?
Yeah, as long as, yeah. And then it's automatically, it automatically comes on when we lose power, and it automatically switches back. It's a bumpless switchback, so you don't even know when it shuts off. It's pretty nice to have.
How big is the tank?
Diesel tank, I want to say like 500 gallons, but I'm not sure. I'll have to look. I didn't know if you guys want to go downstairs.
Sure,
and
sure.
then we'll pop up over at the UV building.
Sounds good.
Hang on, dude.
We got a couple drain pumps over there if we take any basins, any trains offline.
Thank you. treated, but
Not drinkable. Well, not for drinking, but for
Is it? Me too.
Their maintenance cleans, their recovery cleans for organics. So all the solids accumulating on them. Citric acid is for the inorganics. So that's like a one-time per year.
Oh, this is green road.
What?
Do you know what's native heritage?
Yeah, no, I saw the flowers.
What's that? Solar panels and set up?
That's what I was good.
Yeah.
You guys pull out the non-native sheets?
But they wanted this to be, they wanted it to be. Down further?
Well, they're all on the roof. Real nice down there. Yeah, those are the lab techs.
Your buddies, Tina.
That's what I got for you guys.
You work here?
I wanted to